Domain-driven design is not only about writing code, though. Adhering to the DDD practices also implies a heavy communication process between developers and domain experts. It's important to have a direct access to the experts in your problem domain, because it's the only way to get the complete information about the problem you are solving. To get the most of domain-driven design, you should constantly refine your domain knowledge with the help of the experts in your company. And it shouldn't be a one-way process. If you see any inconsistencies in the language the experts use or in the model they draw, state it. It may be that you find a way to describe and solve the problem in a much simpler way than it was proposed in the beginning. Constantly work with the experts and strive to help them simplify or even completely rethink the problem. Your code, if built using the Ubiquitous language, can become a great help for that. You may see some edge cases that wasn't clear enough in the beginning, or you may find how to redefine the problem statement in a much cleaner and more concise manner. Another implication of domain-driven design is that you should always strive to become a domain expert yourself. Software developers are often enthusiastic about coding tasks that regard to building an infrastructure for the future project. Such tasks often seem interesting as they entail some technical challenge. Also, because of their technical nature, the knowledge acquired when solving them can be reused in other projects. All this makes such activities compelling to many developers. Nevertheless, to benefit from the domain-driven design techniques the most, you should always try to dive into the domain you are working in as much as possible. This might seem boring at first and may feel like a waste of time because the domain knowledge you get working on one project can hardly be applied to another, but in the reality it is not the case. First of all, if you obtain deep domain knowledge, it will help you do the best job that a programmer could possibly do. This knowledge will guide you through the code you write and will help you look at it from the domain expert's point of view. This skill is indispensable as it allows you to combine the best of the two worlds, write technically correct code on one hand and express the domain knowledge with it on the other. Secondly, although problem domains are different from project to project, the skill of systematizing them with code is reusable. The more you learn the domain you work in, and the more you try to define it in your codebase, the better you become at it. Eventually, you will see patterns and will be able to work on new domains with ease. And it will also help you learn new domains more quickly. Let's look at the structure of a typical application built with the domain design principles in mind. DDD notions form a construction named onion architecture. It is called so because it resembles an onion with multiple layers and a core inside. Upper layers depend on the lower ones, but the lower layers don't know of the upper. It might seem similar to a classic n-layer architecture, and it is. The difference here is that onion architecture emphasizes the fact that the core part of this structure cannot depend on anything else except itself. It means that the core elements of our domain model should act in isolation from others. This is an important point. We will talk about it in a minute. Let's place the building blocks of domain-driven design in this picture. The core part of the so-called onion is the notions of entity, value object, domain event, and aggregate. The next layer consists of repositories, factories, and domain services. Application services go beyond that, and finally UI is the outermost layer, if of course the application contains a user interface. You might wonder where the database belongs in this picture. All work with the database should be encapsulated into repositories. They can refer to it either directly or using an ORM, but the general rule should remain. The code working with the data storage must be gathered under the repositories in your domain model. These four elements, entities, value objects, domain events, and aggregates, are the most basic. They can refer to each other, for example, an entity can contain a value object, or a value object can keep a reference to an aggregate root, but they cannot work with other DDD notions, such as repositories and factories. Similarly, repositories, factories, and domain services can know of each other and the four basic elements, but they should not refer to the application services. So why this kind of isolation is so important? Why should we keep the four core elements of the domain model separated from others? The main reason is the separation of concerns. Entities, value objects, domain events, and aggregates carry the most important part of the application, its business logic. They don't contain all of it, of course. Repositories and factories can keep some of the business logic as well, but these four elements do include most of it. In the situation where you have some elements so deeply involved in the problem domain representation, it is vital to keep them as free as possible from other duties, hence the notion of separation of concerns. I'd like to emphasize it once again. It is crucial to leave entities and value objects to do only one thing: represent the domain logic in your application. In practice, it means they shouldn't contain any knowledge about how they are persisted or how they are created. These two operations must be up to repositories and factories. They also shouldn't contain any knowledge about the tables and columns in the database where they are stored. This must be given away to data mappers. All they should know of is the domain they represent. Remember, the cleaner you keep your domain model, the easier it is to reason about it and to extend it later on. Inability to maintain proper separation of concerns in enterprise-level applications is one of the biggest reasons why codebases become a mess, which leads to delays and even failure of the project. It is not always possible to separate them completely though, and there always will be some elements not related to your domain you cannot get rid of. An example here would be the necessity to create a parameterless constructor in your entities to satisfy object relational mappers. Nevertheless, it is possible to keep those elements under control so that they introduce almost no overhead to your domain classes. You will see how to do this in practice in the next modules: how to keep the domain model clean, how to maintain proper separation of concerns, and how to deal with the side effects object relational mappers introduce. If you follow DDD principles, the domain model becomes the heart of your software. This fact entails a guideline of how you should work with your application's codebase. Focus on the core domain first and pay the most of your attention to it. In practice, it means that you should always start the development with modeling the core domain. Even if you don't have any UI or database structure yet, start experimenting with the model with the help of unit tests. User interface and the database are important elements of the system as well, of course, but the core domain is the part you should focus on the most. It might be hard to make such a shift, especially if you are used to building software starting from the database structure, but this shift is worth it. The investments in your domain model pay off greatly over time. It also means that in a typical enterprise application, any infrastructure code is less important than the core domain. Make sure you keep your business logic coherent and don't allow it to dissolve in the infrastructure code. When it comes to unit testing, it's important to keep a balance between the test coverage and the amount of effort you put into tests. 100% coverage is an expensive mark to reach, and it doesn't necessarily provide proportional value to the quality of your software. In most enterprise-level applications, the value distribution corresponds to the number of unit tests in this way. You can see that the closer we get to 100%, the less value the additional tests provide us with. At the same time, the amount of effort we put in their creation grows linearly. It means that at some point, the value we get from the additional unit tests doesn't justify the resources we invest in them. This is the point where we are better off to stop building up the coverage, as it wouldn't give us much besides a good-looking coverage number. The exact location of this point would differ from project to project, but the general trend remains. You should employ the same pragmatic principles in an application built with the domain design principles in mind. In practice, it means you should cover with unit tests only those parts of your codebase that are the most significant to your application. And this is the innermost layer in your onion architecture: entities, value objects, aggregates, and domain events, the elements which contain most of the domain knowledge of your application. It's a good idea to get 100% or close to 100% test coverage of them. That is another reason why we should keep the core layer of the domain model isolated from other parts of the application, such as database, email service, and so on. A good separation of concerns helps create testable code which doesn't require any mocks or other test doubles to be tested. If you find your unit test hitting the database or some other external dependencies, it's a strong sign your domain model is not properly isolated. But what about the other parts of your code base? Shouldn't they be covered with tests as well? They definitely should, but it doesn't have to be unit tests. Moreover, we are better off not employing unit testing for those types of functionality, but rather use integration testing instead. That is, automated tests which cover several pieces of the application at once. Throughout this course, you will see this pragmatic approach to unit testing in practice. You will also see how easy it is to implement them due to great isolation we will achieve for our domain model. The topic of integration testing is out of scope for this course though. If you want to learn more about integration testing in the context of DDD, check out my blog post here.